folks, so we're going to go ahead and skip over to page 25, okay? And we're just going to be solving percent mixture problems over here, okay? And again, these ones have a similar format. So we're going to say, we're going to go ahead and say it's going to be, so it's one of my percents times one of the amounts. When I put in the number, I mean some amount, plus another percentage concentration times another amount is going to be equal to the final percent times the final amount. Okay? And this is essentially the kind of setup we're going to be using for each of these. These can be really confusing, but if you just follow this, you should get it right away. Okay? So it says the doctor needs to administer an antibiotic solution to her patient. She only has 2 concentrations of antibiotic solutions in her office. We have a 25% and a 60% solution. She knows that based on her medical history of her patient, the 25% antibiotic solution should be ineffective, and the 60% antibiotic solution would be too strong. So based on her patient's height and weight, she calculates that the patient needs exactly 7 milliliters of a 30% antibiotic solution. So how many milliliters of the 25 and of the 60 should be mixed together? Okay? So what's happening here? So these things here, so what we have, these are what is being, these two items, these are what is being mixed together. So these are mixing together. Oh, sorry. So these over here are mixing together, and this one over here is kind of like my final solution. Okay? So what is being mixed together? So I know, so I'm going to write down my formula again, just to practice, so I know, okay, so I have what? I have some percentage times some amount, plus another percentage times another amount, and that's going to be my final percentage times my final amount. Okay? So what is being mixed in here? Well, I know that I'm mixing a what? A 25% solution and a 60% solution. Okay? Because why? How do I know that I'm doing that? Because those are the only things that she has in her office, right? So those are our percentages here. So we're going to automatically convert this here. The percentage is going to be 0.25, okay? Times, I don't know what this is yet, I'm going to leave that blank, my first amount. The second percentage is 60 here, so I'm going to call this 0.6. And the second amount I'm going to leave blank again, and then these I will leave blank for the time being. What else do I know? Well, it says here, based on her patient's height and weight, she calculates the patient needs exactly 7 of a 30, so she's trying to make this. So she is trying to make. When it says the word make, this means this is the final solution. That's the final solution. So what does that mean? In other words, what is being made is like this stuff here. This is what we want to make. We want to make this stuff here. Okay? So how do I do this? What do I do? Well, I know I want to make what? 7 milliliters of a 30% solution. So that's the final. So it's going to be the percentage is 0.30 because it's 30%, and it's 7. That's the amount. And now what do I need? What do I want? I want to figure out what goes in here. How do I know what goes in here? It doesn't even tell me anything. And I need to figure out how much of each of these. Well, what do I know? I do know in the whole solution, so let's just say that this is the final one, right? I mixed in both of these two things in here. And overall, the total amount of liquid, there is how much? There's 7 milliliters in here, right? Okay? So, let's just say this much of it was the first one here, right? So let's just say, for example, let's just say this was 2 milliliters. What would this one be? That would be 5, right? Similarly, let's just say this was 3. Then this one would be 4. True? So what happens if I call this X? Can you figure out what this would be? I'll give you a hint. It's either X minus 7, 7 minus X, or X plus 7. Which one do you think it is? Because remember, these two numbers have to add to 7. 2 plus 5 is 7. 3 plus 4 is 7. So what plus x gives me 7? And lo and behold, it's going to be 7 minus x. So what does that mean? So we call one of them x. Which one? It doesn't matter. I'm going to call this one x. Why? Because I feel like it. So if I call this x, the remaining amount is going to be 7 minus x. And now I have my equation. It's set up to solve. This is a 30, excuse me. And now we just solve it out. I'm not going to do this part here. So if you look over here in your chart, what is happening? So if this is x milliliters, this one is going to be 7 minus x milliliters here. So that's going to be 7 minus x here. Okay, so I'm just filling in the remainder of the chart. And then again, we would set it up, which is done right over here. And you would go ahead and go through the calculations. Okay, so if you notice, this is how we would solve these kinds of problems. It's actually not too bad. The hardest part, believe it or not, some people forget how to multiply their decimals. You get a little shaky with that sometimes. Okay, we're going to practice another example right now. All right, so here we have Adam is a hairstylist who needs to make a 40%. Oh wait, before we do that, because we have a percent problem, we're going to do percent 1 times my value. It's going to be my percent times my other value equals the final one times my final value. Okay? Okay, so what's happening? So Adam's a hairstylist. He needs to make, which one is make? That's this one over here, a 40% red hair dye solution for his client. Okay? So we already know that this is 0.4 here. Okay? Why? Because that's what he wants to make. He already has 2 ounces of a 20% hair dye solution in one bottle. So so that's 2 ounces in one bottle. So that's what's being mixed. So let's just say that's the first one. So he has 2 ounces of a 20%. That's 0.20. Okay. How many ounces of a 50% red hair dye solution should be mixed with 2 ounces of the 20% hair dye solution in order to make the 40%? Ooh, man, this is so many numbers, so many percentages. Okay, so how do we go through this? Well, let's read it one more time. How many ounces of a 50% red hair dye solution? So which one? So this is done. I already mixed that in here. That's what I'm trying to make. So this is the only thing remaining. What am I mixing in there? I'm mixing in this thing. Well, there's only 1% left, so that must be the 50. So how many ounces of this one? 50. So it's 0.50 is here. And I want how many ounces of this one? So this one is going to be my x over here. Right? You're like, okay, so how many ounces of this one, because that's the amount of this kind, should be mixed with the 2 ounces of the 20%. So I'm mixing this one with this one to make my 40% red hair dye solution. But if you notice, we have another problem. What's the problem? There's nothing in here. Right? You're like, oh, something's missing. And it is in a way. So if we look back over here, so let's just say, for example, I'm going to go back here. So what do we know? We know this here is 2 ounces here. This is x ounces. So remember, if we remember last time, we had, what do we have? We had 3 and 4, and we had 2 and 5, and everybody had to add to 7 each time, right? The total, when we add them, it has to be 7. So the total is just going to be the sum of these two. So what is the total? It is going to be, what is x plus 2? It is just x plus 2. So what does that mean? I.e., these two numbers always add to this number. So it's going to be here, x plus 2. So then I have my setup problem. So I have here 0.2 20 times 2 plus 0.50 or 0.5 times x. Excuse me, this should be equal sign here. Equals 0.40 times x plus 2. Okay? And then we would solve it out. You can solve this one out. If you look down at the bottom here, this is the associated chart with all of the items entered in. So we have 0.2, 0.5, 0.4. Change the percentages to decimals. Here we have the solution amounts to x, and the total is x plus 2. And then the ingredients is going to be the multiplication of those. And here we have the setup problem as we've set it up. And if you solve it, you should get 4 over here. Okay? Okay, last one we would do is none. Okay, so what you should do is you should do this one over here. This classwork on page number 28 to test your skill. See if you can really do these here. Okay, and the rest we will tackle in class. Thank you very much, everybody. So make sure to take notes on this one. I will also email out the homework assignment. Okay. Thank you very much. Take care.